All right. So what I'm about to do is to explain some of the techniques and some of the best practices that we use at Virtusa to address some of the pressing needs in current software industry, where we have to change the way we do things, and how do we cater to these changing markets. So to start this, first of all, now we need to understand why. So let me start with the statement that we all are living in a society of impulses. What does that mean? Now, take an example. If you wanted to buy, let's say, a wristwatch, back in the days, we would go to a shop, look for the best style that you like, and bargain with the shop owner, and you purchase it, right? If you want to buy clothes, you tag along with your best half, go through the Nogegoda shops, spending whole day in the sweltering sun, right? And then you buy some of the clothes. But we no longer do that, right? We tend to do things instantaneously. If you want to open a bank account, you don't wait until the bank open tomorrow. You just go online, fill the form, get the open account, right? And that kind of define the current society as a society of impulse, where we do things on impulses. What does this mean? What does this mean to us, the software guys? To answer that question, first we need to understand what does this mean to the corporations or the industries or the companies. Now, let's take a look at how industries change during the timeline. That will give us some hint. Okay, this thing isn't working. See? All right. Oops, sorry about that. Let's focus on the businesses, how they change during the timelines. If you take a look at 1960s, back in the days, they were trying to position themselves in the market. They were promoting their logos, they were promoting their colors, they were promoting their brand names. That's how they were trying to get into their audience, their customer base. When they move into 1980s towards 2000, just a brand name couldn't do it. It didn't cut. So they had to invent a differentiator. You have to do something different to your competitor. You have to, if you're making cars, you have to at least make a car in a different color. Otherwise, you won't survive. And then it moved into 2000 and beyond. Now, you no longer get to choose what your next product is. Everything is being driven by the customer experience. The customer demands, hey, I need this in my product. I need this in my service. So the businesses now have to cater this demand, right? So you no longer get 3 months to plan your features that you're going to include in your next build, right? Customer, sometimes based on certain technological advances that they see in the market, they want that in their phone. They want that in their service. So you no longer get like whole 6 months to deliver your product. You have to be swift. You have to learn all these new technologies as a software engineer, catering on these customer experiences. You have to go through a lot. You have to change the way you do things. You have to learn new technologies. But you don't have that much time to do all that. That's where the issue is. How do we address this problem? How do we provide a cutting-edge, high-quality software in an ever-shortening timeline? That's the question. To answer this, we get an insight from one of the fastest sports in the world. Let me show you a little clip. This is a Formula F1 pit crew. Just take a look at the slow motion. From the moment the vehicle stops to the moment vehicle goes again, they take only 2 seconds. All right? Within that 2 seconds, they have to do everything and make sure the vehicle is ready for the next run. This is exactly what we have to do now. right? We don't get that much time, but what we do have to be extra precision, high quality, and you have to be very good at what you do in order to deliver things in fast pace. Now, 3 things out of this. To achieve such a high quality in a limited time frame, first you need to prevent waste. If you define waste over here, it can come in multiple forms. One, it may be the waste of your efforts, time, or let's say preventing a disaster in the future is kind of preventing waste, right? If something wrong happens in the future, you have to do all this back rolling, backups, and firefighting. That's a waste. In this particular situation, they change all the 4 tires. That's why. They would have let the driver go another lap or 2. But what if a tire bursts? What if the vehicle spins? That's a disaster. That's a waste. We want to prevent that. And take a look at one of these tires. If you have noticed in your vehicles, there are at least 4 lug nuts connecting your wheel to your vehicle. Now in these F1 vehicles, they only have 1 nut at the middle, because you don't want to do this redundant thing 4 times over. Just have a single nut with the same strength, just remove it. That's reducing waste. The second thing is focusing your efforts. Now, each and every member in this pit crew have a very specific task to perform. Everybody have a time. They all get 2 seconds flat. Everybody have to do whatever the task assigned to them in utmost precision. That's focusing your efforts. And finally, automate the process. Now, back in the days, if you had a puncture, you would take this wheel brush thingy out, remove all the lug nuts, and change the tire. We don't have time to do that now, right? So we automate the process. We have this mechanical nut removers. You just plug it. In fraction of a second, you're done. So these are the 3 things that we adhere to in order to cater this demanding market. Let's take one by one. How do we prevent waste when it comes to software quality? Just as a software quality assurance engineer, for me, waste is something. Let's take the quality assurance as a principle. What we do is basically finding others' faults, right? That's what we do. So how do we prevent the efforts that we spend on finding others' fault? Can we stop defects being defects? Can we prevent defects at their birthplace? That's what we were thinking. That was the line that we were going through. So when we wanted to cater that, when we wanted to prevent waste in the quality assurance industry, we wanted to prevent defects. To prevent defects, we had certain simple mechanisms. You probably have already know things like static code analyzers who goes through the code and understand any code violations. We implement one of those. When the software developer checks in the code into the code repository, some of these bots automatically scan through your code and understand any code violations. These code violations are not defects. Code violations are things like, let's say you open a database at the beginning, you never closed it. There's no problem, the code works fine. But what if you move this into production? There will be hundreds and thousands of open database connections. That's going to be a defect. And that's why this is a violation. You have to follow this best practice in order to avoid a disaster. So in this situation, we have such violations. We detect them using certain algorithms, and we report them back to a reporting mechanism. Okay? Now, we identify the birth of the defect. We identify the violation at the point it happened. But did we actually prevent it becoming a defect? Because finding a defect is not equal to fixing a defect. Somebody still have to go and fix all the defects that we reported in the dashboard. How do you make that happen? You can just point your developer at 100 defects and ask him to go fix, but probably that won't happen. How do we motivate him? How do we get him to get this done? To answer that question, we need to take a look at the species who introduce defects, known as developers. These guys are known as digital natives. They normally expect technology to simplify things, not to make their lives miserable. And the word user manual is not in their vocabulary. They don't look at user manuals. They just do things intuitively. And they want instant gratification. When they post something in the Facebook, they would like likes within 5 minutes. And they crave transparency. They don't like things that are opaque. They want to know how it happens. And they don't care hierarchy. They call your CEO machan. That's the life cycle. And then they are not loyal to your companies. The moment something happens, you just switch the company. But they are loyal to your society. And they are purpose driven. If they don't understand why this is done, they don't do it. So the traditional processes don't work with them. And out of all, average age of one of the software engineers nowadays is 28.9 years. And if you are living in Asia, it's just 25 years. So they are also known as millennials. And if you have noticed, a lot of these people have beards. That's why I had this picture over there. So now we know who these guys are. But how does this address the situation? Now, there's one important fun fact about these guys. When one of these millennials become 21 years old, they have spent at least 10,000 hours playing games. They still have the beards. Now, how do we use some of these facts to get some work done from them? There's this technique called gamification. Have you heard about it? Anybody have heard about gamification before? Raise your hands. Fantastic. So, what we do here is we use some of these gaming concepts into the software development industry. First thing, we still go through and analyze this code that they produce, and we find these violations. Instead of just put them in a simple dashboard, we put them in a gamified dashboard. The difference is we kind of highlight them, promote them, or demote them based on their skill set, based on their quality of work. Now, for an instance, if you fix a defect, we give them a virtual gold coin. If you introduce a defect, we take that gold coin back. So at the end of the day, the one with the most gold coin would be at the top of the game board. And we would give him badges, we would call him different names, we would call him Lord or Sir. And that kind of put them up in their society. Remember, these are society creatures. They like to thrive in high places in the society. So this kind of facilitates that. Now this gamification has 3 very important features. If you're trying to apply this at your organization, you have to first make sure you provide them actionable insight. You can't just throw a bunch of numbers at them and expect them to go figure what to do. You have to tell them, this is the number, this number is because of this, and you have to do this to do that. You have to explain that, actionable insight. And also, you have to motivate them. Now, based on some of these gamified dashboard, you get that motivation. For instance, in Virtusa, we have this dashboard running in all prominent places in high, large displays. So everybody see when somebody get promoted to the top rank, everybody understand, everybody knows him. That's kind of give them this gamified feeling. That's kind of motivate them to go and fix these defects. And after 3 years being deployed this, we have observed about 23% positive variance in technical depth. That means they not only fix their own defects, they fix the defects introduced by others, the ones that were there in the legacy systems, because they wanted to get more gold coin and they went ahead and fixed everybody else's defects. That's how this gamified dashboard concept works. Now, moving into the second piece, focus efforts. When it comes to quality assurance, there's a lot of effort spent on testing multiple scenarios. If you take a complex application today, you can easily get into hundreds and thousands different scenarios that you have to test. But now, the initial issue, we don't have that time, we don't have that money, we don't have that budget to test everything. But can you not test everything? That's also impossible, because we don't want this to fail in the production. Now, how do we address this situation? There have been traditional mechanisms, boundary line analysis, equal partitioning, and things like that. But at the end of the day, you will get these 1,000 test cases that you can't run. So you reduce it to a manageable test set, sometimes based on your gut feeling. Now you are leaving a risk of leaving a defect into production. We don't want that to happen. What we did was we went and did a little research, and we figured out we are not the only one having this issue, number one. And there's this fabulous algorithm introduced about a decade ago known as pairwise algorithm. Anybody have heard about pairwise algorithm? Okay, let me explain how that works. So some of the folks back in the days went into analyzing a lot of defects to figure out why defects happening in the first place, right? And they figured defects are happening in the first place because either one of these developers didn't complete, didn't fulfill, or didn't program a single input parameter properly, or interaction between two parameters are not happening the way they're supposed to. There can be defects because of 3 parameters not working together, 4 parameters not working together, but they are progressively less common, and to find them you have to test a lot, so they are progressively expensive to find. So what they suggest is to exercise the interactions between pairs. When you exercise interaction between pairs, you automatically test all the individual parameters as well. So by applying this theory, you can test your application's risk, about 97% of the overall risk, using a very little number of test scenarios. Without boring you, let me explain this in a very simple term. Imagine you have a software application and it has 3 parameters, A, B, and C. Right? This can be, let's assume, a drop down, a gender drop down, where you have male and female as option. Right? One of those. A can be A1 or A2, B can be B1 or B2, C can be C1 or C2. All right? If you ask to test this in normal fashion, we would just take A1, we take B1 from B, we take C1 from C, and create a scenario. Right? And then we just keep A and B constant, exhaust all the values from C, and once you run out C, you move into the B, get the next value, and likewise, you just do this permutation standard calculation. And you would end up with 2 into 2 into 2, 8 different scenarios. This is how we do things, right? This is how we figure out what are the all possibilities that can happen within this application. But now apply pairwise theory into this. The moment you apply pairwise into this, you still be testing A1 and B1 and C1. There's no change in that. But when you come to your second scenario, you no longer have to test A1, B1, and C2, because imagine if there is a defect happening because A1 not talking to B1 properly. You would already have captured it here because you exercise A1 and B1 together. So doing this again and again and again doesn't give you much ROI. It makes no sense, right? So what you do is you enrich your second scenario with a new set of pair. Now we test A1 and B1 instead. Likewise, every next scenario will be calculated to test a new set of pair each time. That's how this pairwise algorithm works. That way, your scope that you took 8 scenarios to test now can be tested within 4 scenarios. Guys, clear? If you have any questions, we have a panel discussion, so we'll talk about these. I'm going to move into the next section. Final piece, automating the process. When it gets to automation, there are known drawbacks. If you take automation as a concept, you're trying to write code to test code, right? if you introduce, now, writing code is a complex task. That's why there's defects in the code in the first place. Now, can you do a similar complex task to figure out defects in the previous complex task? It's like, make no sense, right? Now, first of all, let me explain the dancer in the left-hand side. You know, it's a Canadian dancer with a one of the Michael Jackson hats doing the moonwalk. Now, what we are trying to depict here is we are trying to address this automation, which is a traditional issue, with a modern approach. How do we do that? First, we had to take away the complexity in test automation. With complexity, you get this need to have specialized skilled people who are expensive. If you want to do a web automation, you would have to find people who know Selenium. If you want to do a desktop automation, you have to find people with QTP. And finally, if you do your automation somehow, when you try to run it, if a single object change in your application, your automation fails. What's the point? You rather do it manually, right? And then, once you write using Selenium, tomorrow your customer will come to you and say, hey, I want to test this in a mobile phone. The Selenium doesn't work in a mobile phone. Now we are locked with a certain technology. We don't want that to happen. So what we do here is we address all these common pitfalls with a framework. First thing we do is we introduce something called Auto4GL, stands for Automation Fourth Generation Language. It's just pretty English-like language. All you need to understand is the command that you're trying to perform. If you want to open something, just say open. If you want to click something, just say click. If you want to type something, just say type. And then this tool prompts you and asks you for all the parameters and syntaxes and everything. It's going to take care of it. So you don't need to remember a lot of commands, the parameters, and it takes away the complexity. It kind of allows automation to get near to people who actually want automation to done, not just the technical guy who understands the automation. And finally, that eliminates the dependency of skilled people. Now you can have almost anybody doing test automation, and this tool have the flexibility where once you write using Auto4GL, this can be converted into the automation language of your choice. Once you write using English, you can convert into Selenium, QTP, SQL, Ranorex, MonkeyTalk, anything, right? And some of the most advanced features in this framework is this generation happens based on a predefined command set. Let's say you have a set of commands that works in Chrome and doesn't work in Firefox. If you do traditional automation, you have to fix this every time. But when you have a framework like this, you just make the modification in the framework. Next time when you say click, it generates that code with the experience behind it, because know what to do when it's Chrome, what to do when it's Firefox. So it carries your knowledge, it retains your knowledge, your experience, and carry it forward. And finally, we use this tool with a factory setting, where we take application access and requirements and test cases from clients, and we go through a technical feasibility studies to understand what if there are any additional needs to change our framework to support the ask. And finally, we go through entry validation. We check their test cases to make sure they are clear enough so we can translate them into automation test cases. And we only start building actual test scripts at the fourth stage. We go capture objects, we write the actual scripts using Auto4GL, we generate the code, and we script review, we run them in bulk, and finally, we do the execution. So this is how we do test automation over at my place. And concluding the session, 3 things when it comes to catering the society of impulse. Number 1, you have to figure out mechanisms to prevent waste. You have to figure out mechanisms to focus your effort. You have to figure out the right mechanism to automate your process. And that's all. Thank you very much.